Okay, so our next unit is all about the absolute value of x. So let's go ahead and start off here by looking at the equation for the absolute value of x. So f of x is equal to, first thing we write is our absolute value symbol, which was 2 bars. That means absolute value. And then we put the x inside. Now, the absolute value symbol is a grouping symbol. So, just like parentheses, absolute value is a grouping symbol. That's very important for when we're using GEMDOS and so on. Next thing we're going to do is we're going to go ahead and go to the parent table, and then we'll graph it. So the thing to keep in mind is the absolute value represents the distance a number is from 0. Okay, so let's go over here to our table, and we'll go ahead and start off here with -3. The distance -3 is from 0 is 3 units. Now we represent distance as a positive number. So when we take the absolute value of a number, it's going to be positive. So let's continue to fill this in. So the absolute value of -2 is 2. Okay, and so on. Absolute value of all of these numbers are positive. Notice the pattern for absolute value. Notice that all the y values are positive. Notice that there is symmetry involved here. And since there is symmetry, there is going to be an axis or a line of symmetry going through the middle. So plotting these points, -2, 2. Okay, so now we're going to go ahead and connect those dots. Good morning, Trevor. Friday morning, Trevor's here for his calculator version of the test. So anytime we have these symbols here with the absolute value, our graph is going to look like a V. So in the name, it kind of gives you a clue as to what the graph is going to look like. Okay, moving down here to example 1. Let's say we want to graph this function here. First thing we want to do here is look at the horizontal change. Notice that it's inside the grouping symbol, which is absolute value. So this means that this graph right here is going to go 4 units to the right. So all of our x values are going to increase by 4. Increase by 4. So our new table for this graph, we're going to increase the x values by 4. So let's see if I can get this to show up together here. There we go. So adding 4, adding 4, adding 4, and so on. Now, what's happening to the y values? It looks like, remember, our vertical change happens on the outside. So it looks like we have a reflection. The -1 on the front is a reflection across x-axis. And then we have a translation, a vertical translation of 2 units up. So we're going to multiply our y values by -1 and add 2 using order of operation. Okay, so 3 times -1 plus 2. So that's going to give us -3 plus 2, which is -1. Okay, following this pattern all the way down, we have -2 plus 2. We have -1 plus 2. We have 0 plus 2. We have where am I at? Here I am. Okay, so 1 times -1 is -1. -1 plus 2 is 1. Notice the symmetry. 6. So this one's going to be 2 times -1 is -2 plus 2. You can see the symmetry happening. So we're going to have -1 here. Okay, so let's go ahead and plot these points. So the parent got translated 4 units to the right, 1, 2, 3, 4, and 2 units up, 1, 2. So there's 4, 2. Okay, 3, 1, 2, 0, 1, -1, and it's going to be symmetrical, so it's going to do the same thing on the other side. Remember, it's going to make a V. Okay, next, write an equation for the graph to the right. So the first thing we want to do here is we want to put in our absolute value. Okay, see, notice that this point right here, I call it my special point because it's the like the vertex, sort of. It's in the middle, and it moved 1, 2, 3 units to the left. So x plus 3 units to the left, and it moved 1 unit down. Now you may notice that this graph has a vertical stretch. It's been stretched compared to this one. So what is that stretch value? Well, if you go over 1 unit from the vertex, okay, you can figure out the stretch by counting up to the graph. So if we count up to the graph, 1, 2, 3, 4. Okay, your A value in this case is going to be 4. Okay, last thing I want to go over real quick is how do you write the domain and the range for an absolute value? Because we can always use more practice with that. So let's take a look at the parent. I'm going to go ahead and stay in interval notation. Domain is furthest left to furthest right. So furthest left is in negative infinity. Furthest right is positive infinity. So there is your domain. And just like quadratic functions, absolute value will always go in negative infinity to positive infinity, even if it's opening down. Okay, so the range is going to go from the lowest point to the furthest highest point. So remember, we're talking y now. So the lowest y value is 0. It's a closed dot, so we'll use a bracket. And the highest point is an arrow. And of course that represents infinity. And so there is your domain and range for your absolute value function. Okay, hope you guys are having a good weekend, and I'll see you on Monday.